All right, for this style of problem, it says find the derivative and then evaluate the derivative at the given point. Now these are really nice when you're given problems like this, because you have both the x value and the y value, and so you don't have to worry about solving things in terms of x and that sort of thing, going back and kind of redoing what you've had to do, and it just makes it a lot easier. And so if at all possible, I would say go for it. Sometimes it's not possible. So, all right, on this first one, let's go ahead and tackle that. First things first, we have to define the derivative. Okay, so let's go ahead and find that. The derivative with respect to x. All right, so we take the derivative of the first. This is the product rule. Derivative of the first times the second, and so we get y, plus the derivative of the second, which is y prime, times the first, which is x, is equal to 0. All right, that means that y prime is equal to negative y over x. All right, you will notice that it says dy dx, and yet I'm using y prime. Again, recall that y prime is in fact the same as dy dx. Okay. All right, so now we've got y prime, and the primes actually work very, very nicely for this, because most people will try to separate these two things, and while that's perfectly legitimate for differential equations, we really don't want to do that here. Okay, and so I go ahead and use the primes in this case because it just kind of works out nicer. And so I'm going to go ahead and evaluate this now. So what I can do is input the values that I'm dealing with. And so now I have y prime. Now y prime evaluated at the point -4 comma -1 is equal to the negative of -1 over -4, which is 1 over -4, which is just -1/4. And there's our answer. All right, so it's really not that bad. All you're doing is adding the second step. Once you find the derivative, you simply have to plug in the values and you're done. Let's do a couple more. Here's a second one here, a little bit more complicated. I thought I'd add some variety. And so we want to go ahead and take that derivative with respect to x. And when we do that, we want to make sure that all of our y's are supposedly functions of x and therefore get the chain rule and the implicit differentiation. So the derivative of the outside is 2y times the derivative of the inside, which is y prime, is equal to quotient rule. The derivative of the first is 2x times the second, or the bottom. I always go tops and bottoms on the quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, now we want to be kind of careful here. We don't want to get lost in our derivative. So let's try to clean this up just a bit. All right, let's expand and see if we can't bring some stuff out, that sort of thing. And so we'll keep this 2y prime over on the left, and on the right, let's expand this out into 2x to the third plus 8x minus 2x to the third plus 8x all over x squared plus 8 quantity. Oh, plus 4, doofball. Got stuck on that whole 8x thing. Plus 4 quantity squared. All right, well, we notice that as long as we do this very carefully, that negative 2x cubed plus 2x cubed goes away. And so I'm left with 2y prime is equal to 16x all over the quantity x squared plus 4 squared. Divide both sides by 2y. And so you have y prime is equal to 16x divided by 2y times the quantity x squared plus 4 squared. 2 cancels with the 16 on top to give you 8 on top. And so we have an alternate form of 8x divided by y times the quantity x squared plus 4 squared. Okay, there we go. All right, now on the side here, let's go ahead and put in our values. So we have the 0.20. Okay, that's what we're going to do over here. So we have y prime is equal to 8 times 2 all over 0 times 2 squared plus 4 all squared. Uh-oh. We seem to have a slight issue here because, well, that y is 0. And so we're certainly going to have an issue because 0 times anything is 0. So we have y prime is equal to 16 over 0, which if we allowed this to go off as the limit, we would recognize as an infinite value. And so here, it appears that we're going to have some kind of an issue of having a vertical slope at this point. And so the best thing to do would be to graph it and see just what's going on. And if you notice here, you have a x squared and a y squared. I'd be looking for some kind of a circle or a curve, some kind of a what could be quite a bastardized conical section. And so I'd be looking at it, I could have possibly some vertical issues. So, yeah, that's too bad. This is undefined. Huh. All that work and it's undefined. Oh well, we know now. Otherwise, we just have to guess. Again, just take that derivative and keep plugging away at it. Oh, another one. I love trig functions. Okay. All right, so here we go. Let's take the derivative. Nice and easy. The derivative of tangent is secant squared. And so the outer thing is tangent. So we go ahead and take that and we put all that junk back inside, but we have to multiply all of that by the derivative of the junk inside. And the derivative of the junk inside is simply 1 plus y prime. And that's equal to 1. Okay. So now we're going to go ahead and we're going to divide both sides by secant squared x plus y. All right, so we get 1 plus y prime is equal to 1 over secant squared x plus y. All right, now before we go on, let's go ahead and change the secant 1 over secant squared, because secant squared is 1 over cosine. And so if we invert it again, it's the reciprocal of cosine. So if we take the reciprocal of it again, we go to cosine. 1 plus y prime is equal to cosine squared x plus y. All right, so now when we do this, it's going to be kind of funky. We're going to subtract 1 from both sides. So we have cosine squared x plus y minus 1. And that for most people would be perfectly normal, and we could leave it like that. However, if we were to refer back to another problem that we did, we noticed that cosine squared x plus sine squared x equals 1. Okay, well now we have, if we subtract off cosine, so we kind of have something that looks like that, we get sine squared x is equal to 1 minus cosine squared x, and now you're going to say, but Phil, wait a minute. We don't have that. We've got 1 minus for the identity, but we've got cosine minus 1 over here. Unless you multiply both sides by negative. So the negative sine squared of x is equal to cosine squared x minus 1. Huh. So now, let's go ahead and use this to our advantage. X, by the way, in this particular thing is just a generic variable. I could have put u in here, which is the way most books actually show you this, so as not to confuse you. However, I'm just going from memory, and so this is the way I remember it. Now, these are just incidentals. They could be anything you want it to be inside. the relationship doesn't change as long as everything that's inside is the same. Okay, so we're going to go ahead and say that, oh, anytime we see a cosine minus 1, we're going to put a negative sign squared. So we have y prime is equal to negative sine squared x plus y. Now I'm very happy. Okay, nice and simple. And so let's go. Oh, we have 0, 0. That's always a lot of fun because everything just kind of goes away. And so if we put our point 0, 0 in, then we get y prime is equal to negative sine squared 0 plus 0, which is y prime is equal to negative sine squared of 0. Sine of 0 is 0, and so you get y prime is equal to 0. There you are. That's all it is. See, implicit differentiation is not that hard.